Hey guys, welcome to yet another video on our channel. So we have started complete lecture series on partial differential equation. Already we have uploaded plenty of the videos on differential equation topic. So as board exam is coming closer and closer, we have to practice only the previous year question from the board exam. So in my previous video, I already explained plenty of the topics and the example based on these topics. Now in our today's video we are going for some of the previous year questions from the board exam, plus we will recap some of the important topic which is very much important for our board exam. Okay, so let's get start our today's lecture, which is a previous year questions from the board exam. Along with I will explain some of the topics. Okay, so it is a complete lecture series. I have already uploaded plenty of the videos on our channel. Okay, so if you are interested to see similar videos, you may check it into my playlist. Okay, you can see more videos based on these topics on our channel. Okay, so here in our today's video, so we'll go for the learning of a differential equation and some of the examples with a different method of a differential equation. Okay, based on the standard form like a parametric differentiation, logarithmic differentiation, implicit differentiation, using composite function of a differentiation, we will learn it here. Okay, so let's dive it into our today's lecture. So we'll see how the examples are coming. Okay, so here in our okay, so before I start my today's lecture, okay, I wanted to explain here some of the basic concept which is important. Okay, so you all are familiar with the first principle of a differentiation, okay, which is a limit h tends to 0, f of x plus h minus f of x upon h, which is the first principle for finding the differentiation of any of the function. Okay, so in such a case we cannot find in most of the case we cannot apply the result as a first principle. Why? Because it is a time taking, and in our board exam we don't have sufficient amount of a time. Okay, so that's why we have to solve our example within a limited time. Okay, stipulated time we have to complete the example. So we have to directly apply the results, standard results from the differentiation. Okay, so the part which coming from the first principle, if you wanted to understand this part, you may check it into my playlist. Okay, so you will get the similar videos. So let's get started our today's part. Already you all are familiar with the first principle, so I'm not gonna explain first principle here. I will explain to you all logarithmic differentiation, after that parametric differentiation, implicit function differentiation, and the using composite function, okay, differentiation. Okay, what is mean by composite function differentiation? Okay, so whenever we have function under function, that time we apply the composite function differentiation in order to find out the differentiation. Okay, yes, so using composite function differentiation we can resolve this calculation very much easily. Okay, so first I wanted to explain to you all here logarithmic differentiation. Okay, logarithmic differentiation. So what is mean by logarithmic differentiation? Take the meaning for logarithmic differentiation as per the word. Logarithm means the word quantity which is coming from the log. Okay, quantity coming from the log, we consider it as a logarithmic differentiation. Okay, so we have to apply some of the results from the logarithm, like log of a upon b, log of a into b, again after log of a to the power b. So like an exponent rule, multiplicand rule, subtraction, division, addition, same type of the rule we have to apply in our differentiation. But why we needed these rules in our differentiation? Because of that these rules can solve our example in the simple format. Okay, in most of the situation whenever we have multiplication of two different function, okay, and these two different function are quite bit difficult for finding their solution. So in such a case what we do, we try to apply log to the all sides and we explain this part. Okay, now for example let me explain logarithmic differentiation. If I consider log of x into y, so we can write log of x into y as a log of x plus log of y. Okay, so log of x into y can be written as log of x plus log of y. Okay, So in some cases x and y both are having some difficult type of the function. Okay, so in such a case it is quite difficult to find out their differentiation using bipart rule. Okay, so whenever we have product, that in such a case we apply the bipart rule for the differentiation. Okay, like we know that differentiation of d by dx of u into v. Okay, so we write first function as it is differentiation of d by dx of v, okay, plus second as it is differentiation of d by dx of u. Okay, so this is the bipart rule for the differentiation. Okay, so we apply this rule whenever we have the multiplication of two different function, but in most of the situation we cannot apply. Okay, we cannot apply directly bipart rule. So in such a case we can go for log of x into y, that is a product rule for a logarithm. Okay, so again there are so many rules like exponent rule. Second, if you go through the exponent rule, okay, which is a to the power x. Okay, and exponent rule, what it does, when we have log of a to the power x, so we can take that x as a multiplicand into log of a. So this one is the let me write this one. Yeah, so this one is a x into log of a. Okay, this one we consider it is the logarithmic exponent rule for logarithm. Okay, using this one we can solve the example easily. Okay, so this all come under logarithmic differentiation. Okay, whenever we go for more example we can understand it easily. Okay, so let's go for the next part. After logarithmic differentiation we know that it's a parametric differentiation. Okay, so parametric Okay, there are some many other topics also, different type of the differentiation also there, but we'll see only the standard form, which is very much important for our board exam. Okay, because these lectures I'm taking it only as a recap for our main concepts. So we don't have sufficient amount of time that can we go for all the topic together. Okay, so if you are interested to see all the topics in detail, you may comment in me in a comment section, or already some of the videos are there in my channel. You may watch this video from my channel. Okay, so parametric differentiation, what it is meant by parametric differentiation? Now till this moment we differentiate our function with respect to x or with respect to y. Okay, till this moment we have differentiate the function with respect to x or with respect to y. Now what happen if we differentiate function with respect to function? Okay, what will happen when we differentiate function with respect to function? It comes under parametric differentiation. Okay, so for parametric differentiation we differentiate our function with respect to given variable. If the function which is there in the form of a theta, so we differentiate with respect to theta, and then we'll proceed for finding its a dy by dx as a differentiation. Okay, it comes under parametric differentiation. Okay, now after that implicit function differentiation. So what is meant by implicit function differentiation? So whenever we have x variable, y variable, all the variables are coming together, like y which is equal to x plus 2y, something this type of the variables are there. Okay, y which is equal to x plus 2y. So we differentiate our function with respect to x. That means differentiation of x gives with respect to x as a 1. And we also take the differentiation of y with respect to x, like a dy by dx. Okay, so which comes under implicit function differentiation. Okay, okay, this one comes under implicit function differentiation. Okay, I hope you all have understood. These are the mainly topics. So why I explain these topics? Because you all need to know these topics before we start solving the examples. Okay, so these are the main topic. I am expecting that you all have understood it well. Okay, even after, if you want to learn more topic or more example, let me know in my comment section. Okay, now let's get start some of the previous year questions from a board exam. Okay, so these are all are asked in our board exam. Okay, all these questions from a board exam Okay, so all are the latest questions, okay, which comes in a March 2018. Okay, March 2018, asked for 4 marks. Okay, very much easy solution is this one. Okay, so we can get this type of the solution in a 4 to 5 steps only, but we just need to know the basic concept which we can apply there. Okay, so here we can see we have two differentiation, two different function. Okay, x which is equal to a cos cube t, and second y which is equal to a sin cube t. We have two different function. Sorry, we have two different function, and we have to differentiate both of them. Okay, so both of them we have to differentiate with each other. Okay, like differentiation of x with respect to y, or y with respect to x. Okay, so here we can see we have to show that dy by dx as a negative of a y by x to the power 1 by 3. Okay, that means we have to differentiate our y with respect to x. Okay, and we know that the parametric form of a differentiation, it says that if you want the dy by dx, so if you want the dy by dx, we differentiate dy with respect to given variable. Okay, now here we can see our x is having variable t. Okay, our x is a function of t. That means we have to differentiate our x with respect to t. Okay, so we'll get it here, dy by dt upon dx by dt. Okay, so we'll get the dy by dt upon dx by dt as a differentiation of dy by dx. Okay, so this is the definition for parametric function. Okay, so we will apply this definition here. Okay, and then we'll go for the calculation. Okay, now see that we have the two different function. Let's go for the solution. I'm expecting that you all have understood. Okay, we have x which is equal to a cos cube t. Okay, x which is equal to a cos cube t, and we have y which is equal to a sin cube t. Okay, so we have two different function, and we want the dy by dx. Okay, that means we have to differentiate dy by dt first, and then next dx by dt. Okay, let's find out the dx by dt. Okay, so dx by dt means a differentiation of x with respect to t of a cos cube of a into cos cube of t. Okay, okay, this one is a into cos cube of t, a differentiation of a into cos cube of t. So go for the differentiation, take a constant term out from our differentiation, a out here. So d by dt of cos cube of t. Okay, d by dt of a cos cube of a t. So take the differentiation, a constant keep as it is, cos cube of a t having differentiation. So cos cube of a t having differentiation, cos having differentiation. Now x raised to n, first of all we have to apply. Okay, cos cube of a t and cos t to the power cos to t to the power 3, both were having same meaning. Okay, so don't get confused about these terms. Okay, you all need to know that cos cube of t which is equal to cos of t to the power 3. Okay, both are having same meaning. Okay, so cos cube of t, that means n x raised to n minus 1. So 3 cos square of t, that means n minus 1 means 2 minus 3 minus 1, which comes 2. Okay, and differentiation of a cos t. Okay, so we know that differentiation cos of x is sin x having differentiation cos x, and cos x having differentiation minus of sin x. Okay, multiplied by minus of sin x. Okay, so this one is the value for dx by dt. So I got the value for dx by dt. Now let's go for the value for dy by dt. Okay, so dy by dt, that means differentiate our y with respect to t, a constant, take it out, then d by dt of sin cube of t. Okay, d by dt of a sin cube of t, just replace the values. Okay, so a constant out already there. Okay, sin cube of a t means sin t to the power 3. Okay, that means sin cube of a t which is equal to sin t to the power 3. So apply n x raised to n minus 1 as a result. Okay, a into 3 sin square of a t. Okay, 3 sin square of t, that means n 3 sin square, that means 3 minus 1, which gives us 2. Okay, 3 sin square of a t, and after that differentiation of a sin t. Okay, so you have to take differentiation of a sin t. Okay, d by dx of sine t. Okay, this is a composite type of the differentiation you all need to understand. Okay, so as solved as per the composite type of the differentiation. Okay, differentiation of a sine t. Now we know that cos is having differentiation negative of sine, and sine is having differentiation cos. Okay, okay, so our answer is 3 times a sine square of t, and differentiation of sine of t is a cos of t. Okay, so this one is the value for dy by dt. Okay, so this is the value for dy by dt. So we have the value for dx by dt, and what is the value for dx by dt? Here it is. We found it earlier. Okay, again dy by dt, which is equal to 3a sine square of t into cos of t. Now what we want the value for dy by dx. So for finding the value for dy by dx means what we want the value for dy by dx means we want the value for dy by dt. Okay, we want the value for dy by dt. Now substitute the value for dy by dt, which is here 3 times a sine square of t cos t. Okay, completely divided by dx by dt. Okay, so what we have here for dx, we have dx by dt. Substitute this value 3 multiplied by a into cos square of t. Okay, into negative of sine t. Sorry, it is not the x, because we are taking with the differentiation t. Okay, so negative of sine t. Okay, so cancel, those are the possible from the numerator and denominator. Okay, so what we have possible, 3a possible, cancel it. Okay, cos t and cos square t, one of the cos get cancelled, sin square t and one negative of sin t, one sin t get cancelled. So numerator left here with the value of sine of t. Okay, and denominator left here the value of negative of cos of t. Okay, sin t divided by negative of cos of t value is there, which is a value for dy by dx. Okay, so we have to show that dy by dx as a negative of y by x to the power 1 by 3. Okay, so our dy by dx we found it here, but this is not the final answer. That means we have to go for the further calculation. That means we have to substitute the value for sin t and cos t from our example to our last step. Okay, so put the values from example. Okay, we have x is equal to a cos cube of t. Now try to create the value from cos t from our example and substitute in the place of sin and cos. Okay, now see that how I'm making the value for cos and sin here. Okay, so take that a to the other side. So we'll get the x divided by a, which is equal to cos cube of t. Okay, so take the third power, 1/3 power from the both side. We'll get the x by a to the power 1 by 3, which is equal to cos of t. Okay, so we got the value for cos of t as x by a to the power 1 by 3. Similarly do it for the value for y. So we'll get the y by a to the power 1 by 3, which is equal to sine of t. Okay, so we got the value for cos of t and sine of t. Now substitute these values here. Okay, so which is a dy by dx. Okay, so value for sine t, y by a and to the power by 1 by 3. Okay, and completely divided by negative of cos t is having value negative of x by a to the power 1 by 3. Okay, now here we can see denominator a to the power 1 by 3 and a to the power 1 by 3. So we can cancel this denominator here. So our numerator it comes as a y to the power 1 by 3 divided by negative of x to the power 1 by 3. Okay, so y to the power 1 by 3 divided by negative of x to the power 1 by 3. So take it together. So what will get the last step here? Y by x and negative out here to the power 1 by 3. Okay, so we got the value here for dy by dx, which is a negative of y by x to the power 1 by 3. Okay, this is our required proof. This we have to prove here in our example. Okay, I'm expecting that you all have understood this solution. Nothing is difficult here. We just have to substitute the value from dy by dx here. Okay, okay, so for the value of x and y, substitute after getting the answer. Okay, this x and this one is y. After getting the answer, substitute this value in our given proof. Okay, you will get the required answer. Okay, I'm expecting that you all have understood this solution. So even after, if you found anything difficult in our solution or a question, let me know in comment section. Okay, I will come up with the same videos. Now here we can see we have the this question asked for 4 marks in March 2018 board exam. Okay, now see that how easy type of the questions are coming, and this type of the questions helps you to make your score higher in your board exam. Okay, so I'm expecting that you all have understood. Let's go for the next example. Now see that in our next example, we have to find the derivative of a cos inverse of a x with respect to square root of 1 minus x square. Okay, now see that till the moment we have learned differentiation of x with function with respect to x, with function with respect to y. Now this is the time to understand differentiation of function with respect to another function. Okay, that means differentiation of cos inverse of x with respect to 1 minus x square. Okay, so this one is quite much easier, that we have to differentiate our function with respect to x, this one with respect to x, and take their reciprocal. You will get the required differentiation of our function. Okay, so let's get start our solution. Okay, so what we do here, we apply parametric type of the differentiation. We apply parametric differentiation. Okay, we apply parametric differentiation here. Okay, so after applying parametric differentiation, we'll get the answer. Okay, so consider first function as the f of x. So now you all have to understand the differentiation of a cos inverse of a x. Okay, inverse functions are having some standard form. Okay, so to prove this standard form, it is quite a bit time taking. So instead of that, what you all need to do, you all have to prepare these results. Okay, try to remember these results so you can understand them, you can remember them at the timing of exam. Okay, and while solving example again and again, I don't think so these are difficult to remember. Okay, so differentiation of cos inverse of x, which is equal to, let me write the differentiation, d by dx of cos inverse of x. Okay, so what is the differentiation of a cos inverse of x? Okay, sin inverse, cos inverse, and tan inverse. These three differentiation are very much important. Okay, so differentiation of cos inverse of x, which is equal to 1 minus 1 upon under root 1 minus x square. Okay, this one is the differentiation of a cos inverse of x that we have to apply over here. Okay, and the root of x, also we needed a root of x differentiation, which is a 1 upon 2 times root x. Okay, now consider first function f of x here, cos inverse of x. Okay, and another function g of x here, square root of 1 minus x square. We have two different function. So differentiate first function with respect to x, that means derivative of f of x with respect to x. So what will get the df of x by dx, which is equal to d by dx of cos inverse of x. Okay, and similarly differentiation of g of x. Okay, so d by dx of g of x, which is equal to d by dx of square root of 1 minus x square. Okay, this one is the differentiation of g of x. Okay, so we have two different function, differentiate both of them with respect to x, because we have function f is in the form of x, so differentiation of f with respect to x we want it here. And similarly the differentiation of g of x, our function is in the form of x, so we needed the differentiation of g of x with respect to x here. Okay, so cos inverse of x is having differentiation, so we will apply that differentiation as it is. Okay, so minus 1 upon square root of 1 minus x square. Okay, this one is the differentiation of f of x, and the differentiation of g of x, square root of 1 minus x square. What will get the, so d derivative of f of x divided by dx. Okay, that means derivative of f dash or f of x, it is there. Okay, similarly d by derivative of g of x d by dx, which is equal to differentiation of root of x, which is a 1 upon 2 times root of x, 1 minus x square, and function it look like a composite type of the function. So differentiate 1 upon x square further also. Okay, subsequently we have to differentiate 1 upon x square. So when it is having differentiation 0, okay, and minus x square having differentiation minus of 2x. Okay, minus x square means x raised to n, which having differentiation and x raised to n minus 1, okay, which is a minus of 2x. Okay, so we can cancel that 2 to this one. Okay, so derivative of a g of x with respect to x can be written as minus x upon square root of 1 minus x square. Okay, so now apply the definition for differentiation of a parametric function. Okay, so differentiation of parametric function, what it says that we want the derivative of cos inverse of x with respect to 1 minus x square. So that means derivative of this function divided by derivative of this function. So you will get the required differentiation. Okay, so how we write the derivative of cos inverse of x? It is here negative 1 upon square root of 1 minus x square. Okay, and completely divided by differentiation of a square root of 1 minus x square, which is a minus x upon square root of 1 minus x square. Okay, now we can see that numerator denominator of a denominator, it goes to the numerator, so minus x goes to the denominator, and square root of 1 minus x square, it comes as the numerator. So you can cancel them directly from here. Okay, that negative also get cancelled, and our required answer, it gives us 1 upon x. Okay, so we got the differentiation of a cos inverse of x with respect to square root of 1 minus x square, which is a 1 upon x. Now see that how easy solution it is. Okay, you need to apply some of the basic concept, you will get the required answer. Okay, I'm expecting that you all have understood my solution. Okay, now let's move for the next example. Okay, we have the next example which asks for 4 marks in a March 2013 board exam. Okay, we have given simple polynomial here, and then we have to show that d square y by dx square, which is equal to 0. That means double differentiation of our polynomial, it gives us the value 0. Okay, so now see that sometimes we have to apply substitution in order to get the answer. Okay, because we don't have the value for x and y, so in such a case try to create the value from our function. Okay, we need to extract the value from our function, then it is easier for finding their differentiation. Okay, now let's go for the solution. So what we do here for finding their differentiation, our function says that x square plus twice of hxy plus by square, which is equal to 0. First of all, find out their differentiation with respect to x. Okay, so we'll get the dy by dx as differentiate directly. Okay, dy by dx 2 times ax. Okay, directly I'm taking differentiation direct into the steps. Okay, because if you go through the separate d by dx and then their differentiation, it will take more time. Okay, so sometimes whenever you solve the example, automatically you can solve these examples inside your head. Okay, we don't need the notebook and book at always time. Okay, so sometimes you have to find out the differentiation directly. Okay, 2 ax square having differentiation 2 times ax. Okay, twice of h. Okay, differentiation of x and y. Now see that x and y, we have two different function, so we have to differentiate x and then we have to differentiate y. Okay, so that means we have to apply by part rule. 2 times h under differentiation of x, that is differentiation of y, which is a dy by dx. Okay, plus y as it is differentiation of x, which is a 1. Okay, so we cannot write it is the 1 there, plus b into 2y dy by dx. Okay, b into 2y dy by dx. B square y is there na, so b constant as it is, y square having differentiation 2y into dy by dx, which is equal to 0. Okay, now see that take the similar term common from here and create the value for dy by dx, then subsequently go for the differentiation of y dy by dx one more time. Okay, so what we have here, these two terms gives us the value dy by dx. Okay, 2 times h x dy by dx. So what the value here, 2 times h x dy by dx, 2 times hx dy by dx plus 2 times by dy by dx. Okay, so these are the two terms having value dy by dx. So remaining term to the take to the other side. So 2 times ax, it goes to the other side as a negative 2 times ax, okay, and 2 times hy, it goes to the negative 2 times hy, okay. Take dy by dx out from here. So dy by dx out from the both term. So 2 times hx plus 2 times by, okay, which is equal to negative of 2 times ax negative of 2 times hy, okay. So we want the value for dy by dx. So leftover term take to the other side, okay. So what we have here, dy by dx as negative, take out from here, take again 2 common, negative 2 common from our steps, okay. So we'll get the ax plus hy, okay, x plus hy. What I have done, I take a negative 2 common from these two terms, okay. So left term here negative 2 under bracket x plus hy. Again do it similarly for here, take 2 common from here, again hx plus by coming here, okay, 2 to get cancel. So our required answer for dy by dx, which is equal to negative of ax plus hy upon hx plus by is there, okay. So we have two different we have dy by dx, it is here, okay. Now after that we want the double differentiation. We have to find out the one more differentiation for our function, but before we find the differentiation, we have to find out the value for x and hy, hx and by here, okay. So x and hy we need to find out the value, because if you go through the directly differentiation of as a u by v, it will be more complicated answer, okay, and we do not want such a complicated steps in our solution, okay. So try to find out the value for x plus hy upon hx plus by using our given x square plus twice of hxy plus by square, which is equal to 0, okay. Using this function we have to find out the value for x plus hy and hx plus by, okay. So for finding their value, so x plus hy, so what we do here, x square plus twice of hxy, expand it here. So let me write their solution, x square plus twice of hxy, I written as twice of hxy as a hxy plus hxy in order to make the value simpler or simplify in simpler form, okay, by which is equal to 0, okay. So these are the just easy calculation. You may go for finding their constant term, take the similar term common from there. So you will get the term as a ax plus hy, you will get the similar term, okay, x plus hy. I am not going to explain this one here, because this type of the calculation are quite easy, that you can solve it by yourself, okay. Even after if you found difficult, let me know in comment section. I will explain this part in my next lecture if you found difficult, but I don't think so is anything difficult here, okay. Need to expand this term and you will get this term, okay, negative of x plus hy upon hx plus by, okay. So whenever you expand this term, you will get the negative of x plus hy upon hx plus by as a y by x, okay. After expansion of this term, you will add on this term, okay. So by calculation you may have to find yourself, because this will be the time taking, so I'm not going for this part, okay. So substitute this value negative of x plus hy upon hx plus by as a y by x. So you will get the value for dy by dx as a negative of complete value, which is a y by x here, okay. Negative of dy by dx, which is equal to, we will get the value for it is a y by x, okay. Yes, now after substituting these values, we get the dy by dx as a y by x, okay. Now let's go for the finding one more differentiation, okay. One more differentiation we want it here, okay. Next differentiation, take one more differentiation for this function. How can we go for the differentiation dy by dx? So you may take x here and y here, okay. So we'll get the differentiation after finding the differentiation of this one, okay. Now we can see that x square plus twice of hxy plus by square, which is equal to 0 we have here, and d square y by dx square, we have to show the double differentiation as a 0, okay. Now dy by dx is a y by x. Now for finding the differentiation, take v into derivative of u into u into derivative of v upon v square, okay. Directly apply by part rule, quotient rule for the differentiation. Now check it out, where it is, what is the value coming here, d square y by dx square, which is equal to y by x. Okay, that means x, that means we have to find out the differentiation of y by x. So if you are going for differentiation, maybe it will be more complicated. So what we can do, more steps here. Okay, dy by dx, which is equal to, yes, yeah, we can go for the directly differentiation, v into derivative of u, x into dy by dx. Okay, x into dy by dx. Okay, minus v into derivative of u minus u means into derivative of u, y into dx by dx, which is 1, okay, upon v square. That means we get the x square here. Okay, so d square y by dx square, which is a x into dy by dx minus y, okay, upon x square. Okay, now we can see here the value for x into dy by dx. Can we create the x into dy by dx value here? Now we can see that d square y by dx square, we got the x into dy by dx. Okay, now try to find out the value for x into dy by dx here. X into dy by dx. Okay, x into dy by dx. What I have done, I taken that x to the here, so it goes to the multiplicand for dy by dx, which is equal to y. Okay, so this is the complete term as a y minus y as it is upon x square. Okay, so y minus y, which is a 0 upon x square, we got the value 0. Now we can see that how easily we got the proof d square y by dx square, which is equal to 0. Okay, now in some condition, what happen, we cannot predict the next step. Okay, at that means we have to solve further and further till we get the last step. Okay, we need to solve it next and next step. So after solving this one, you will get the answer 0. Okay, I'm expecting that you all have understood this solution. Nothing is difficult here. Okay, let's move for the next example. So maybe two more examples are there. Okay, yes, x is equal to a into t minus 1 by t and y which is equal to a into t plus 1 by t. Then we have to show that dy by dx which is equal to x divided by y. Okay, now these two are the two different functions. So differentiate with respect to parametric function. Okay, so my previous example, it is also similar like this one. So I feel that you all have to go for this solution. Okay, similar like a previous example, we have to solve this one. Okay, so if you go through directly differentiation of a dy by, so x we have here, let me explain what we need to do. X, we have x is equal to, we have x which is equal to a into under bracket t minus 1 by t. Okay, this one is the value for x, and the value for y which is equal to a into t plus 1 by t. Okay, so we have to differentiate x with respect to t and y with respect to t. Then you will get the by parametric function dy by dx as a dy by dt upon dx by dt. Okay, so we have to find out the dy by dt and then divide this term by dx by dt. So you will get the value for dy by dx. Okay, okay, so what is the value for dy by dt? So you have to differentiate y with respect to t. Okay, so you will get the value for dy by dt, and similarly differentiate x with respect to t, you will get the value for dx by dt, and substitute both of these values in our parametric type of a differentiation. You will get the required answer as a dy by dx as a x divided by y. Okay, so I don't think so I have to explain this simple type of example. Okay, so I kept this example, I keep this example for you all. Okay, so do it for your homework and tell me the answer in comment section. Okay, and if you found anything difficult, let me know also in comment section. I will come up with the same examples, or I will solve this example in my next lecture. Okay, so I'm expecting that you can solve this example. I'm expecting that you all have understood my previous part, and that next example you may have to solve by yourself. Okay, nothing is difficult. Now next part is here, y which is equal to tan inverse of x square we have given. Then we have to show that 1 plus x square bracket square into d square y by dx square plus 2x into 1 plus x square dy by dx minus 2 which is equal to 0. Question asked in March 2015 for 4 marks. Okay, that question asked in March 2015. for 4 marks. Okay, now let's go for the differentiation. Differentiation, it is quite much easier here. Okay, so what we do here, first of all, differentiate tan inverse of x, okay, to the power n, that means n x raised to n minus 1. So what we have here, y which is equal to tan inverse of x to the power 2. Okay, so differentiation as with respect to x, so we get the dy by dx as a 2 times tan inverse of x to the power 2 minus 1. That means it gives the value 1 only. Okay, so we cannot write as the power of power to the power 1, okay, for our function. So into d by dx of tan inverse of x, okay, we into d by dx of a tan inverse of x, and tan inverse of x, what is the differentiation of a tan inverse of x? 2 into tan inverse of x into differentiation of a tan inverse of x, 1 upon 1 plus x square. Okay, this one is the differentiation of a tan inverse of x, which is the value for dy by dx here. Okay, so we want the value for this differentiation. Okay, we want the value for this differentiation. That means you can see it here, the double differentiation, it is also part of our function. Okay, so try to differentiate it one more time. Okay, so you will get the required steps. Okay, so what we do here, dy by dx, so take this term to the other side, 1 upon 1 plus x square, take this term here, so you will get the simplified form. Okay, because if you go through directly multiplication by part rule, it is quite a bit confusing here for solving this example. Okay, so 1 plus x square, take to the other side, multiplied by dy by dx, which is equal to 2 times tan inverse of x. Okay, so we have 1 plus x square dy by dx into 2 times tan inverse of x. Okay, now we can see that here, so we can easily apply by part rule here instead of a by part rule in between these two functions. Okay, so we can directly apply by part rule here, so we'll get this required step. Okay, now let's move for the to apply by part rule in our function. Okay, okay, so here apply by part rule to our function. First function as it is, 1 plus x square. Now keep 1 plus x square as it is. Differentiation of a dy by dx with respect to x, it gives us a d square y by dx square. Okay, plus first function as it is, differentiation of a second, plus second function dy by dx as it is, differentiation of 1 plus x square. Okay, so when it is a constant term, that means there is no rate of a change, so differentiation of 1 it constant term is 0, and differentiation of x square, it is a 2 times x. Okay, so differentiation of x square, which is a 2 times x, which is equal to 2 times tan inverse of x. Okay, so we want the differentiation of tan inverse of x, that means 2 times d by dx of tan inverse of x. Always remember that we are taking constant term out from our bracket in order to find out the required differentiation. Okay, so 1 plus x square divides d square y by dx square, dy by dx into 2x, 2 times d by dx of tan inverse of x. Okay, so differentiate this one, so we'll get the next step as a right hand side I am writing here only, 2 times tan inverse 1 upon 1 plus x square it is coming. Okay, okay, so take this term to the other side, so this come as a multiplicand here, so 1 plus x square into 1 plus x square, so we'll get the 1 plus x square to the bracket 2. Okay, so d square y by dx square keep as it is, d square y by dx square as it is. Okay, yeah, this term as it is. After this, after that we have multiplied 1 plus x square here also. Okay, plus, okay, plus 2 times x as it is, 2 times x we keep as it is. Okay, and multiplied by 1 plus x square is there, 1 plus x square it is there. Okay, into dy by dx, which is equal to remaining term here at this side only 2, so take this term also to the other side, we'll get the negative 2. Okay, now observe this term and our required proof what we want here. Okay, now see that there is similarity between them, both are exactly same. Okay, so there is no difference between these two terms. That means we found our required proof by using our differentiation. Now see that this question asks for 4 marks. Nothing is there, just a basic concepts are there. Okay, I'm expecting that you all have understood this complete solution for my example. Okay, so even after, if you found anything difficult, let me know in my comment section. Okay, so in my today's video we have learned here, first of all, the differentiation using first principle. This is the just only recap video, so I'm trying to revise only the concept, not explaining all of them here. Okay, so if you want to see all the explanation together, you may check it into my playlist. Okay, comment me in a comment box, so I will come up with the more videos. Okay, and subsequently we learn parametric differentiation, logarithmic differentiation, differentiation using composite function. Okay, so I'm expecting that you all have understood my today's lecture based on the differentiation and different type of the differentiation. Okay, that's it only for our today's lecture, so we don't have more example. This is the last example. Previous example I kept it for your homework. Okay, do we try to solve this example, do it by yourself and tell me the answer in my comment section. Okay, so I hope that you all have understood everything from my today's lecture. So thank you everyone, thank you for my today's lecture.